the topic is ellipse on the subject engineering graphics applicable for students studying BE BTech first year. A cone is taken and look onto the base shown yellow in color. This will be the center of the base and this is called as base diameter. Okay, it's shown yellow in color and the top portion is called as the apex part of the cone, APEX apex. Now we're going to cut this cone inclined to the base. So forming at an angle called theta. When I cut using knife, this will be the removed portion and this will be the retained portion. Lower portion is the retained portion and the cut portion is shown blue in color, is the formation of ellipse. It's a closed curve. And how to draw this ellipse? The method used is called eccentricity method, which I'm going to explain following a question. And look onto this profile, removed portion, we'll have this profile called ellipse, a closed curve. And this corner is called as, like a corner, is called as vertex part of the cone, indicated by letter V. And this will be the opposite vertex, marked as V dash. This is the first conic section called as ellipse. It's a formation of ellipse or origin of ellipse. Okay. Please read the question. Draw an ellipse, eccentricity as 2/3 and the distance of focus from directrix as 52 mm. Also draw tangent and normal at any point on the curve. So here the eccentricity value is given as 2/3 and the distance of focus from directrix is given as 52 mm. 52 mm means 5.2 centimeter distance. In the side of a drawing sheet, you can work out a simple calculation. Eccentricity is indicated by small letter E is equal to 2/3. So when you put it using calculator, you will get 0.66. Is value less than 1. Suppose if eccentricity is given as a 3/4, you will get a 0.75. If eccentricity comes less than 1, the curve obtained will be ellipse. So add the numerator and denominator of eccentricity value. Here it is 2/3, so 2 plus 3 is equal to 5 parts. Again E is equal to, numerator 2 is given, so 2 parts, denominator 3 is given, so 3 parts, is equal to VF by VO, the ratio. V stands for vertex, F stands for focus, O stands for origin. Okay, so using the draft scale or by using roll-on scale. Here now I'm going to explain using roll-on scale. First you draw one vertical line marked as A and B of any suitable length, is called as directrix. This is fixed vertical line called as directrix. So put any point or mark any point on this vertical line. Okay. So draw one horizontal line using the, when you draw the horizontal line called as axis of ellipse, ensure that there is one product arrangement is given. In that 90 degrees should coincide with this directrix. So adjust your scale and draw one horizontal line called as axis of ellipse and extend the line further. Axis, so that this angle will be 90 degree, that you have to ensure. Okay, this point of intersection shall be marked as O. Okay, so now I'm going to mark the distance of focus from the directrix is given as 52 mm from point O. 52 mm means 5.2 centimeter, 5 centimeter plus 2 small divisions will give you 52 mm. This point of location shall be marked as focus F. Next we will dimension this 52 mm. So again you draw one parallel to this directrix, roll your roll-on scale and draw one extension line at point F and parallel to the axis, the scale edge and the axis line must coincide. Draw a line called dimension line below the axis, somewhere below the axis, to mark the size or the length of the line is given as 52 mm. Put 2 narrow arrowhead, shade the arrowhead and you can write the length of the line as 5.2. Don't write mm, number alone is sufficient. Now I am going to divide this segment OF into 5 equal parts. Here by calculation I got 5 parts. Suppose 3 by 4 means you will get 7 parts. Like that you have to do the calculation part. Okay. So 2 plus 3 is equal to 5 parts. Now I am going to divide this OF into 5 equal parts. For that I am going to follow one procedure. Draw one inclined line of any suitable angle. Any angle you can draw one inclined line from point O. The length of the inclined line is chosen in such a way that it is easily divisible by 5. For example, if I take a 50 mm inclined line length means 50 mm I taken. So that each segment 50 divided by 5 will be 10 mm. That is 1 centimeter. So for every 1 centimeter, mark on this inclined line. Okay. So let me number as 1, 2, 3, 4, 5. Okay. So now join 5 and F by Roland scale. Adjust your scale. Join 5 and point F. With the same setting, just you slide the scale or roll your scale from at point 4, draw inclined parallel line. With the same setting, you have to do it just by rolling the scale. Okay. Now OF has been divided into 5 equal parts by this procedure. Let me number this 1, 2, 3, 4 and 5. Fifth point is F, stands for focus. Fixed point called focus. Now this is step 1. Now I am going to draw several vertical lines. Before that, the ratio given is 2 by 3. So 2 parts is equal to VF, 3 parts is equal to VO, the ratio. Put on the simple calculation part. So VF corresponds to numerator 2 parts. Now I am going to mark the point called V, vertex, on this numbered 1, 2, 3, 4. Where it will come? I think it will come on the third segment. So 3 corresponds to V. So that VF will be 2 parts. 3 to 4, 4 to 5, 2 parts. And VO will be 3 parts. 0 to 1, 1 to 2, 2 to 3. So like that you have to divide the segment and mark the point called vertex V. It is based on the eccentricity value, it is plotted, okay, or marked. Now I am going to draw a vertical line parallel to 3, that is passing through point vertex. So again this edge of the scale must coincide with this directrix line and roll your Roland scale. The scale is moved. So at point V, draw one vertical line at point V. Okay. Now take your compass. V as a center and VF as radius. V as a center, VF as radius. Draw an arc upward. So this arc where it intersects with the vertical line is marked as, say, any letter you can provide. Let me provide Z. Okay. Join O and Z. Join OZ and extend the line further. So all these works shall be carried out by using 2H pencil, okay, called as construction lines. The final curve is to be drawn by using H or HB pencil, appears to be dark. Okay, so now next step is I am going to draw several vertical lines parallel to directrix. This is directrix. So parallel to directrix, move your scale. Anywhere this line shall be drawn. Between 3 and 4, I draw the first vertical line. Okay, like this. Second vertical line, let me draw it between 4 and 5. Anywhere this shall be drawn. Okay, and extend the line below also, below the axis. So you can give uniform gap or non-uniform gap also between the gap between the vertical lines. So like that you draw several vertical lines. Or you can take 1 centimeter gap between the vertical lines drawn. For easy understanding, I will explain this. So this is the first vertical line. Okay, this vertical line where it intersects with the axis is at here. This point shall be marked as say 1. Where it intersects with the OZ line. It intersects, this is 1, intersects OZ line at here. This point shall be marked as say 1 dash. This is second vertical line, shall be marked as 2, 2 dash, 3, 3 dash, 4, 4 dash. So like that you mark several vertical lines. For before that you will mark, let me take a 1 centimeter gap between the vertical lines. On the axis mark 10 mm gap. You can maintain this uniform gap or non-uniform gap also. Your answer will not change. Okay, where all you marked, there you draw vertical lines parallel to directrix. So you have to align your scale parallel to directrix. Draw several vertical lines wherever you marked. Extend the line below the axis also, like this. Okay, this is a fifth vertical line, sixth, seventh, eighth, ninth, 10th, 11th, 12th. This will be 5 dash, 6 dash, 7 dash, 8 dash, 9 dash, 10 dash, 11 dash, 12 dash. Okay, now take your compass. Take one dash vertical distance in your compass. Okay, FS center. F is at fifth point. FS center of your compass. Cut a arc on the first vertical line. It cuts it here, above and below the axis. So let this point be marked as, this point shall be marked as a P suffix 1. Similarly, below the axis, this is the point marked as a P suffix 1 dash. Understand? The same procedure is repeated for all other vertical lines. Take 2 dash vertical distance in your compass. F as center. Cut a arc on the second vertical line, 2 dash vertical line. Cuts it here. Similarly, third vertical line, T3 dash distance is taken in the compass. F as center. Always the fixed point focus will be the center for cutting the arcs. Next, 4 dash vertical distance is taken in the compass. F as center. Cut a arc on the fourth vertical line. Next, 5 dash distance is taken in the compass. F as center. Cut a arc on the fifth vertical line. Repeat the process for all vertical lines. Always F will be the center for cutting the arcs. Next, the seventh vertical line. F as center. Eighth vertical line. Ninth vertical line. So okay. So let me give number to the points obtained. This is P suffix 1. This will be P suffix 2, P3, P4, P5, P6, P7, P8, P9. Similarly, below the axis also you give name to the points obtained. This will be P suffix 2 dash, P3 dash, this will be P4 dash, this will be P5 dash, P6 dash, P7 dash, P8 dash, P9 dash. Similarly, you take 10 dash vertical distance is taken as a compass. F as center. Cut a arc on the 10th vertical line. It cuts it here, above and below the axis. This is P10. This will be P10 dash. So draw a smooth curve passing through these obtained points starting from point V. V is our vertex. This is third point is our vertex. First you draw lighter line, very lightly. A smooth curve is drawn. Your hand should bend. Not turn, don't turn your drawing sheet or the drawing board. Try a smooth curve passing through these obtained points. Up to 10 we marked and below the axis also. Join with vertex V. Join V with P suffix 1 dash, 2 dash, P suffix 3 dash. Okay. So now this is our vertex. Similarly, we have to find opposite vertex. At somewhere at here it will come. So where it will come, we don't know so far. So the gap between the vertical line is reduced. The gap between the vertical line is going to be reduced. I have drawn the axis vertical lines. So this is the curve is diverging. After that, it will converge. At converging point, you will get opposite vertex. For that, the gap between the vertical line is reduced. Instead of 1 centimeter, 1 centimeter, we have to reduce the gap. Where it will come, we don't know. So draw after 10th vertical line, the gap is reduced. Say I draw one vertical line randomly at here. Okay. Let me check. This comes for opposite vertex. Take the vertical distance in your compass. That is between 10 and 11. I have drawn one vertical line. That vertical distance is taken in the compass. Keeping F as center, cut a arc on this 11. That is on that vertical line. So it is not coinciding with this point of intersection of the axis and the vertical line. It doesn't coincide. So you have to reduce the gap. So again you draw one more vertical line somewhere after 10th vertical line. So reset your draft, what is called as a roll on scale, parallel to this edge of the directrix. So roll your scale. After 10th vertical line, let me draw a vertical line at here. Take that vertical distance in your compass. Keeping F as a center. Cut a arc on that vertical line. It is also not coming. So again you reduce the distance. After 10th point, you roll your scale like this. After 10th vertical line, you minimize the gap. I drawn one vertical line at here. Okay, take that vertical distance in your compass. And keeping F as center, cut a arc on this 10th, after 10th vertical line. It's obtained. That is, this will be the opposite vertex marked as V dash. What I want to say is, in which vertical line it will come, we don't know, that V dash. That vertical distance is taken as a compass. F as center, cut a arc on the vertical line. The point of intersection of the vertical line and the axis, that the point should coincide when you cut an arc from focus. You will get a single arc at the point of intersection of the vertical line and the axis. You will get only one single arc. That confirms opposite vertex marked as V dash. Like that you have to obtain. Join P10 with V dash. With P10 dash also. So this, and let me dark this. So you can use HB or H pencil for drawing this smooth curve called as the ellipse. Okay, here I use a different color. Don't paint the curve. It should be a single stroke or single pass. So this is vertex V, P1, P2, P3, P4, and below the axis V, P1 dash, P2 dash, P3 dash. Like that you join all those points by H or HB pencil. It's one of the answer. asked in the question to draw an ellipse is to be highlighted. Don't paint this curve. It should be single stroke and single pass. Suppose if it goes wrong means you can erase that part and redraw. Yeah, this closed curve is called as ellipse. Whatever the profile obtained on the left hand side should have the same profile on the right hand side also. That forms ellipse. Okay. Next, what is asked in the question? Also draw tangent and normal at any point on the curve. Let me mark one point. Somewhere anywhere below the axis or above the axis, I locate one point at here. So let me mark this point as P. For this point P, I am going to draw tangent and normal. So join P and F by ordinary scale or by roll-on scale. Join P and point F. Okay. By using this ordinary scale, at a point F, the corner of your scale, or by you can use set square also for drawing this tangent and normal. Here I use ordinary scale itself. At a corner of your scale should coincide with a PF line and the F point should coincide with the corner. Using this another edge, or you can follow like this. You turn your scale, join PF. At point F, the corner should coincide. At the same time, this edge, the smaller edge of the scale should coincide with the PF line. At the F, you draw one line like this. Okay, using another edge of your freehand scale. This line, this angle between this PF line and this drawn line should have 90 degrees. That is a concept. Okay, so this line where it intersects with the directrix is marked as, say, T. It intersects at here. This point shall be marked as T. Join TP. Join T and a point located at point P. This forms tangent. And extend this line further. T dash is a tangent, and this is a located point P. So use here I use ordinary scale itself. So draw a line perpendicular to T dash, perpendicular to T dash at point F. The corner of the scale must coincide with the point P, located at point P. This smaller edge of the scale should coincide with this T dash line at point P. Using the another edge of your scale, draw a line like this and extend this line further, that is below the point P. This will be marked as N dash, called normal. The angle between normal and tangent will be 90 degree. You can check it using protractor. Okay. And yes, dimension 52 mm. So next you have to dimension what is called as, you have to write all dimensions are in mm. So right side lower part of your diagram, draw two guidelines using pencil, and you can write common representation. All dimensions are in mm. Mm means a millimeter as a unit followed. The curvature ellipse, tangent and normal shall be drawn by using H or HB pencil, appears to be dark. All other lines shall be drawn by using 2H pencil, called as construction lines. All dimensions are in. Writing work shall be carried by using H or HB pencil. So one who reads the drawing shall be able to understand the notations. So this is this method of drawing ellipse is called eccentricity method, as eccentricity value is given in the question. And thanks for listening. Yes.